prepared for the demo, and then also some techniques. And then we will then go into the process with GeoMagics to prepare the scan data before we hand it over to ExactFlat. So for today, we actually used our IronScan HX, which is a hybrid laser and structure light scanner. So it uses both technology, blue laser for high fidelity, accurate scans, and also structure light for more rapid and more feature-based scanning and full color scanning. And this is actually very useful in this type of application for automotive. And in a lot of cases, we can do many things in order to collect the data. So the HX is a very perfect scanner for this type of industry, especially for flattening objects. So again, this HX has a laser scan built in, blue laser. It also has color and structure light. So we have we put a lot of hard work into the HX, and we keep on updating our HX software too in order to help with this technology. So even with our field of view, we are able to do really large surface areas, which you'll see why that matters here. So again, really good point range for small details all the way to larger panels, which we will show. So again, we got different types of accuracy from 0.4, 0.04, sorry, 0.04 millimeters in laser mode to 0.05 in rapid mode for accuracy. So the application today, we actually scanned this beautiful Mustang, and this was part of our one of our partners up in Ace Engineering. They provided this beautiful Mustang for us to scan and to flatten. So in this case, we were able to actually one second. We're able to actually scan in full color. And also, there's a video here. I might quickly play the video through another means really quick. So right here, we can actually show the Mustang in action. Really quick confirmation, can everyone see the video?
I can see the video.
Great. So in this case, we can actually use a no markers. And doing, if we don't need high accuracy, we can actually capture a lot of the engine bay for reference and for spatial reference. So in this case, we're actually scanning in color mode. So that's one thing that HX has a really strong feature to be able to do, is to scan with many different types of features. Another one is actually, we can actually scan with laser. And in this mode, we actually have some of our higher accuracy. Again, if this is something where you have a very symmetrical or very interesting surface where there's no features to detect or any colors, we can use marker-based alignment. And in this case, we have a kind of a special technique in order to scan for the car. We have kind of prepared kind of with markers these little triangles in order to put over the car. It literally takes a minute to put on and take off, and I'll have a little bit of a fun tack to stick on. It's very easy to put on the car without any residue, and it's no mess right here. So let's get into it. From the laser mode, we actually prepared the data. So in here, we'll kind of go over how to prepare the data that we collected in the HX on laser mode. And this is the data that we acquired, and we're going to be opening it up in GeoMagic's Essentials to be able to get it ready for ExactFlat. So right now, we're going to save it. And in this case, I'm not going to save it as an STL. I'm actually going to save it as a point cloud. So I've opened it up in GeoMagic's as a point cloud. If you notice, I haven't actually scanned the whole bumper. And in a lot of cases, you can scan the whole bumper if you want. But in this workflow, I'll actually show you a clever way where we double only one side of the scan. And then what we'll do is we'll double it and make a left and a right. And as you can see, we're about to mirror it over so that the point cloud will have a left and a right. So right now we have a left and a right side mirror, because often or not, and when we're doing something very symmetrical, we don't have to do as much work. We can sometimes just scan just one side and kind of do the alignment later. So inside GeoMagic's, we're kind of taking some points that are very similar to each side, and we're just kind of doing a endpoint registration. So I'm taking some features that I see that there are some commonalities to, and you can see it kind of did a basic best fit, and now we're registering it to more perfectly combine on the point cloud. Very cool. So now we have our bumper that we need, and right now we're just kind of turning it from a point cloud into a tessellation. So in this case, we need to just kind of mesh it out a bit, and now we have it as a mesh. Now we can work with it. So when we did that, we have all this extra data that we don't need to have. So we're going to kind of go through and clean up. Again, like the markers that I placed, I'm going to delete those. And I can hit manifold and kind of reduce some maybe floating points that are not related to the actual body. And as you can see, I'm kind of selecting more of the areas, kind of going through, cleaning up more of that data. And then if you want, once you get kind of a good spot, you can go in and you see the area that we want to actually flatten. We're going to start selecting that and make it a more like what we actually want. And notice there's some noise in some areas from when we were kind of aligning the data, and that's okay. We'll talk about that in a bit. But we're just selecting data and kind of getting it prepared. So instead of having the whole file, we don't really need all this data for the part that we want to flatten. So I'm just kind of going through and selectively going through. There we go. So just however much you want to put into it, whatever part of the data that you need to acquire. So we're going to just select that. And then right around here, we're going to actually revert all that we've selected and delete all the unnecessary data. And I'm going to save this so that we have this as a separate file. And I'm going to go in and kind of do some more cleanup of maybe some areas I forgot. So one of the really powerful tools inside GeoMagic's for preparing it is that we can do selective filling. So if there's a hole on the edge that's not really kind of not all the way there, we can actually fill those in. So just going in, filling in the data. So we have different types of hole filling technology with flats, tangents, and curves, depending on what we need. So filling in where maybe there's some hole data that we absolutely need. And notice maybe we filled in a little bit wrong. We can always defeature areas in order to make more perfect mesh. So going in, and we still have this kind of noise from when we align the data. So what we're going to do is reduce the noise. And there you go. Reduce the noise a bit. The data is getting a little bit better right there. We'll go in, and every once in a while we will go in and look at the mesh repair and make sure everything's good. So now what we're going to do is notice on the side of the mesh, there's always all these jagged areas. So what Geomagic will do is we can actually go in and tighten up a lot of the jagged areas and create kind of a tension and pull that to be really nice and clean. In some cases, it doesn't always work, as you can see that, but luckily enough for us, we can also do partial so that we can tighten just a little bit at a time so that we can get a much better mesh quality. So just kind of go in and selectively tighten things. So just do a little bit more of the same. Again, just kind of find some areas and you can overlap on some areas. And if you don't like the how some data will look, you can always select a new area and try that out. So kind of tighten up some of these edges here. So now that we're finally finishing up our edge tightening, we're going to go start in and maybe do one more reduction of noise just to clean it up. And we can look at the deviation to make sure that we're not too far from the original mesh. And then one more time, clean up the data, do some mesh doctor repair. Now that we have a pretty good mesh, what we're going to do is we're going to break these up into smaller panels for the flattening side. So if we bring it into ExactFlat as a whole piece right now, it might need it might not flatten. So we have to separate and find like lines where we can actually trim. So inside Geomagic Essentials, we have the ability to kind of go in and follow creases and kind of make selective panel cuts for what we need to export. So going through, making a quick crease there. And these are where I'm going to make my cuts to export as an individual file. So here we go, just doing a couple more cuts. And if you can see, now we have 1, 2, 3, 4, 5, 6 different panels. And sometimes we just kind of experiment and see what we need. So that looks pretty good. So what I'm going to do now is turn those lines into boundaries. So what that actually did is it separated the mesh so that it can actually, they're now separated from each other. So this whole piece is made up of different regions. And in order to save them out as different objects, what we're going to do is we're going to duplicate the main file 6 times. and then maybe a seventh so that we can have the original file. Just name them 1, 2, 3, 4, 5 as different panels. And then we're going to select panel 1, and then we're going to do a boundary selection, and then we're going to reverse it, and then delete everything that's not that panel 1, and do the same thing for panel 2, 3, 4, 5, and 6. So now we have these 6 separate files. And what we want to do in order to save it and get it ready for ExactFlat, we want to save it as a .obj file so that we can kind of keep the UV texture mapping for it. And there are some applications that guys at ExactFlat will bring up. So, and there we go. We have our 6 OBJ files now. And if you can see, it's just made up of, each file is just made up of individual panels. Now that we have these panels ready from our original scan, we're kind of ready to hand it off to the wonderful people at ExactFlat.
All right, thanks, Grant. It's for everybody listening, it's Eaton here, and I'm joined by my colleague Luke Noransky, who is a senior application engineer. And I just want to recap sort of what happened so far, and then tell you what's going to happen next. So we start with the scanning process, and typically to scan a bumper, you're looking at about 5 minutes or so, under 5 minutes. You could do it faster, it may take a little bit longer. You want to make sure that you get the detail necessary, that the data is captured so that you can have an accurate subsequent patterning process. You delete the files, or you delete the sections of the data that you don't want. You fill in holes, you defeature and smooth the surfaces, you reduce the noise, and you smooth edges. That's really it. So while the video was moving, or the demonstration that Grant was giving was moving, at a good pace, there's really 5 steps. Delete the unwanted sections, fill in holes, defeature and smooth. You can reduce noise and smooth the edges. And then the last step is you can cut it up into panel pieces as appropriate. Now, Grant did demonstrate the cutting up of panel pieces. We thought what we do here is we would have a slightly different version that is cut up into different panel sections, and that is really to mirror what's going to happen with the commercial templates that are available. So we want to show you something that's analogous to the commercial templates. And as you can see, Luke is sharing his screen right now, and this is the part that has been brought into ExactFlat. And you can see it's in 2 pieces. So we're going to flatten 2 pieces. Now, I will say that ExactFlat is a 3D to 2D conversion utility for pattern making. So if you want to make paint protection film, if you want to scan interior pieces of a car, say seat trim, door panels, consoles, dashboards, whatever it is that you're making, and that you're capturing the data with the EinsCan, you can use ExactFlat to create the flattened pieces that would be put together in a certain way. We're going to give you a little bit of a bonus as well. The bonus is we're going to show you how to potentially add value to your paint protection film by putting graphics on it. And Luke is going to take you through the process there. So I'm going to stop talking now. I'm going to hand it off to my colleague Luke. Luke is one of the world leading experts in 3D to 2D flattening. Luke, why don't you go ahead and take the presentation from here?
Thank you, Eaton. So we've got the bumper that was scanned with the EinsCan and processed with Geomagic, and we've brought it into Rhino here. I've already done a bit of work on this, so I've taken the 6 pieces that Grant prepared, and I've joined these together into 2 different pieces here. And this is to mirror the commercially available templates that already exist for this particular vehicle here. And additionally, if I switch over to our rendered view, I've also applied a graphic to this here. So I've already done some basic texture mapping. You can use pretty much any utility that you want to do your texture mapping, whether it's Rhino or 3D Studio Max or Blender. It really doesn't matter which utility you use, so long as the graphics on there, if you choose to do graphics. And ExactFlat will flatten the graphics as well. So we're going to go back to our shaded mode for the time being. And not only am I going to flatten this object with the graphics, we also have some text here. So if you wanted to put some text on there, or if you need to mark the location of a cutout, you might have like a an access hatch here for a charge port or for a jack or something, or if you wanted to mark a location of cutout for whatever it may be, you can do that as well. We can flatten curves and points on the surface of the mesh as well. So for this demo, we've got the text ground effects here. We're going to flatten that text onto the pattern as well. So I've already prepared this for flattening. We've got our two pieces here. So the first step is to use our flatten command. So it's the very first icon in the toolbar. We're going to select both our 3D model pieces, and very quickly we end up with our initial unoptimized 2D flat patterns down here. Whenever we do flattening, ExactFlat will please create two new layers in the layers view over here. So ExactFlat will keep all of your data separate. It's very easy to manage and work with. So for now, we're going to focus on our ExactFlat pattern layer, and we're going to turn everything else off. We want to focus on our 2D pattern pieces for now. I'm also going to leave our perspective view, and we're going to focus on the top-down view. So my top-down view is still in rendered view, so we can see the texture has been flattened along with the pattern pieces. But for now, we're going to switch back to shaded mode. ExactFlat operates as a two-stage flattener. We've got our first stage flatteners are what take our 3D model pieces, and they convert, they take the 3D shape and they flatten it down to some kind of 2D flat pattern. We can see we've got different colors on the mesh here, and the color represents the quality or the accuracy of the pattern, with white being no strain, cyan is 5%, green is 10, yellow is 15, and red is 20% or more. So as we do our flattening, ultimately we want to see our patterns turning white. That's going to indicate that we have no strain. So we can see here that we've got quite a bit of strain. That's okay. These are only the first stage flattening. The second stage is going to be the optimizer. Sometimes what might happen is we may have folds or wrinkles. If that happens, you'll notice them as black cross marks. And we can fix those using what we call our pre-flatteners. These are the first stage flatteners. We're also going to help minimize a lot of the strain using one of our pre-flatteners as well. And for this demo, I'm going to use our Smart Fracture pre-flattener. It's the very first one here. And with this tool, we pick a spot on the mesh. We can see the different triangle edges are being highlighted. So we're going to pick an edge somewhere in the middle, preferably along a plane of symmetry. And we're going to click, and we can see the tool's pushing all of that material out to the sides. And after running this tool, the color has now changed to pretty much all white, which tells us we have very little strain, if not no strain on this part whatsoever. I'm going to repeat this step for this part right here. And again, we can see the tool's pushing all of the material out to the sides, and the color is changing to almost all white. So just at a very quick glance, I can tell that I've got very little strain on this piece here, and that's just from the color. We have other ways to tell how much strain is on the pattern piece as well, and we'll talk about those in the next step. Depending on the material you're working with, for paint protection films, some of them are fairly rigid. They don't have any stretch, and in that case, you want as little strain on your pattern as possible. Other materials are more of a stretchy film, in which case you might want to cut your pattern a little bit small, so you have to intentionally stretch it to get it to fit. And if that's the case, we do have a tool that helps with that as well. It's called our Global Target Strain, and it's tied into our grain line. We need to identify the orientation or grain direction of the piece in order for the global target strain to work. So I'm going to go ahead, I'm going to add a grain line using this tool right here. And for grain lines, we simply pick an edge that's running in the direction or the orientation of the grain edge. So for this piece here, I'm going to pick an edge right on the boundary, and I'm going to say that this boundary edge here is going in the direction of the grain of my material. For global target strain, we want to turn the tool on, and this tool works by intentionally straining the part either in the principal or the transverse direction. Principal direction would be in the same direction as the grain line. So for this piece here, the principal direction would be from side to side, and transverse is perpendicular to the grain line, or for this piece, it would be up and down. So we're going to add principal strain. In most applications, you only want to add a couple % strain for this type of film. Depending on what you're working with, you might want to add more. So global target strain is really good for paint protection film that needs to be shrunk a little bit. It's good for medical applications like compression stockings, or anything that really needs to be under tension when it's placed back onto the original form. So I'm going to go ahead and set 2% principal strain here, and I'm going to go ahead and click OK. I'm going to repeat that process For my second piece down here, I will turn on global target strain, set 2% principal strain, and click OK. Now that I've added my grain line, I can go ahead and start the second stage of flattening. I can do the optimizer, and this is the tool that's going to minimize the average energy density across the entire surface of the pattern to as close to 0 as possible. ExactFlat does come with a number of different materials here. Unfortunately, we don't have a paint protection film in our library right now. However, it's very easy to get your own materials into our ExactFlat material database. We can share details with a lab that does the testing for us, so that's something we don't mind providing. It's very quick, cheap, and easy to get your materials into ExactFlat, so that's not a barrier at all. But for the purpose of this demo, I'm just going to go ahead and use our default cotton here, and I'll go ahead and click OK. So very quickly, the optimizer is going to start running. It's working on this top piece here first, and already it's done. We can see after optimization, the piece has turned pretty much light cyan. That's telling us that we've got probably about 2% strain on this piece here. We did add target strain to this piece, so we aren't expecting to see a pure white piece. We are expecting to see a little bit of color because we are intentionally shrinking the piece. So we have to intentionally stretch it to get it to fit back onto the original form. So that's why we're seeing a bit of color there. We'll see the same thing happen to this piece down here once it's finished optimizing. So while this is optimizing, we've got quite a bit of different information being displayed over here. The key piece of information that we want to look at is this one right here, the average energy density. And right now it's telling us we have an average energy across the entire surface of our mesh of about 0.1 Newton meters. To put this into perspective, if we were to have on average 1% strain across the entire surface of our pattern, we would expect to see an average energy density of about 0.39 Newton meters. So this is telling me that we've got about 0.25% of strain across the entire surface of our pattern right now. That makes sense. The global target strain is the last thing that's applied to the mesh. So once we've finished optimizing, the global target strain will take effect, and then we'll see that number jump a little bit up here. But while it's optimizing, we can see that we're getting a very accurate result. The shape that we have is very closely matching the 3D shape.
So
We
let me
also
interrupt for let me interrupt for a second, if I could, Luke, please. So
Sure.
for those people who don't know what strain and energy density is, let's just have a quick conversation about what is strain. Can you talk a little bit about what strain is?
Yes, so strain is just a measure of how much the 2D pattern has shrunk relative to the surface area of the 3D model piece. So if you compare the surface area of the 2D pattern piece to the surface area of the 3D piece, strain is just a measure of how much the 2D pattern piece has shrunk relative to the 3D model piece.
So
So
that
when we look
means
at
that,
this piece here, so
go
when we
ahead.
look at this piece here, it's shrunk by about 2%. The surface area of our model piece here, or sorry, our 3D pattern piece here, or 2D pattern piece here is about 2% less than the surface area of the 3D model piece, which means we're going to have to stretch it by about 2% to get it to fit back onto the original shape.
Right. So we sometimes describe that as the amount of elongation that is necessary that you have to put on the piece to have it fit properly. And for those of you who are paint protection film professionals, you know that the film in many instances or many types of film is designed to stretch. So this will give you an indication of how it is supposed to stretch. Simple example, if your piece is 100 centimeters long, and if you stretch it by 2%, you're going to have to stretch it by 2 centimeters. So let's just talk then about energy density. If you can make a quick comment about energy density.
So we measure our strain in energy density newtons per meter. So that's just over a 1 meter distance. That's how much force you would have to apply to that piece of material to get it to stretch to the original shape. So for this piece here, piece 2, our average energy density finished off at about 0.65. That's roughly, when we look at energy density at 0.1 or at 1% elongation, that tells us that we have on average about 2% strain here, or we would have to stretch our material over the distance of 1 meter. We would have to stretch it by 0.66 newtons to get it to reach its actual final shape, the correct length.
Right. So while strain is a measure of elongation or shrinkage, depending on which perspective you use, energy density refers to the amount of force required to achieve that elongation. That'll be different depending on the type of material you're using. If it's a stretchy material, then your energy density required will be less than if it's a non-stretchy material. ExactFlat does work for metals and composites and leather and things like that, things that are traditionally not that stretchy. So in those situations, you'll want your patterns to be as close to zero in energy density as possible. Okay, Luke, as the process is just coming to an end here, I'll just hand it back to you.
Sure, so optimization's finished. The last thing I want to mention is our no seam stretch error here. So this is the final way that we can gauge the quality and the accuracy of the pattern. For a perfect pattern, we'd have no seam stretch error. What this value represents is the deviation of 2D perimeter length. So if we measured the entire perimeter of our 2D pattern piece here, this number here would be the difference between the perimeter of the 2D piece and the perimeter of the 3D model piece. So for this piece here, we have a no seam stretch error of about 150 millimeters. We do have ways to reduce this even further if this is too great. But again, to put this into perspective, the boundary length of our 3D model piece, we report that over here, and the perimeter length of our 3D model piece is just over 9 meters. So we have a no seam stretch error of about 151 millimeters over 9 meters, so that's very, very small, and that's just another way that we can gauge the quality and the accuracy of the pattern. Color, of course, is going to be your primary indicator. That's the easiest thing to recognize. You can adjust the colors used in ExactFlat as well. So right now it's set to cyan. We can see the entire surface area of our pattern piece is cyan. I don't see any green here, so that's telling me that we are well below 5% strain across the entire surface of our pattern, and that's the primary way to gauge the quality and the accuracy of the pattern. So optimization is complete. If we switch back to our rendered view, we can see we still have our texture here. ExactFlat's, whenever we make any kind of change to our pattern, whether we're pre-flattening or optimizing, the texture is constantly being reflattened to match the shape of the pattern. So we haven't lost our texture. At this point, we are going to go ahead. I'm going to trace that text. So if we go back to our 3D model over here in our layers view, I'm going to turn on our 3D model. We're going to go back to our perspective view, and I'm going to turn on the text layer so we can see we have our text right there. And the next thing I'm going to do, I'm just going to move this pattern piece to the side a little bit, is we are going to trace and flatten this text onto the 2D pattern, and we're going to use our trace tool to do this. I'm going to start the tool. I select my text. I'm going to pick a target piece, this one here, and we're just going to go ahead and click OK. And very quickly, we're going to see ExactFlat trace that text onto the 2D pattern piece. So any kind of change I make to the pattern here, just like with the texture, this text is now being flattened along with the pattern piece. The last thing we're going to do here, we're going to turn off our model layer again and the text again. We're going to focus on our pattern once more. Is we're just going to orient our pattern pieces here. So this piece already looks good. It looks like it's in the correct orientation, but this one up here is kind of rotated a bit. So I'm just going to use the Rhino rotate command. I'm going to zoom in on the corners here, and I'm going to use these corner points as references. I'm just going to rotate that piece so it's perfectly horizontal. So at this point, we have our flattened pattern. We have two options. If we are simply interested in cutting out a paint protection film, then we can use our export option. So we're going to click our DXF export button here, and this is going to export our pattern as a DXF. So I'll just call this pattern, and then very quickly I can drag this back in and we can have a look at the pattern. And this is just going to create a DXF version of the pattern for us. There it is. And what ExactFlat does is it's going to smooth out the boundaries of our patterns. So it's going to interpolate smooth curves and create our DXF as a series of polylines. So even though our DXF might look a little polygonal around the perimeter, if we look at the pattern, we can see ExactFlat smooths that out for us. If, however, your intention is to send this to a large format printer for plotting, if you're interested in graphics, we can use ExactFlat to render these to graphics. We can either render to a TIFF or PNG or PDF, and we're going to use our ExactFlat graphics and texture package for this. And All you do is you set your desired resolution. I'm going to leave it at 150 dpi. As a general rule here, if you are using graphics, we recommend your source texture be at least twice the resolution as the output resolution, and that's just to ensure if there is any kind of compression or expansion of the pattern piece. You just want to make sure there's enough resolution in your source texture to accommodate the expansion or contraction of the pattern piece. So we'll go ahead and we'll click next. We're not going to do any kind of post-processing work to the texture. Our texture is already black and white. Depending on your needs, you may need to convert your texture from color to grayscale or black and white. You do have that option here, but for this, we're just going to click next. And at this point, we can pick our output format. So we support PDF, PNG, or TIFF. If you pick PNG or TIFF, it's going to simply render your pattern piece as a graphic. Any part of the graphic that is not occupied by the bumper will be rendered as transparent. If you pick PDF, you also get your cut information. So I'm going to select PDF here. I'm going to output our cut line, our grain line, and our marking line. So that would be the text that we've traced here. And I'll go ahead and click render. And very quickly, this is going to create renderings of our pattern pieces. So there they are right there. And here's the resulting PDFs. And if we open that and drag it back, we can see we've got our PDF right here. So just like with the DXF, everything comes in on different layers. We've got a print layer for our graphic. And if we turn that off, we can see our different cut layers here. So we've got our cut layer, grain line, and lastly, our markings, which is our text. So that's about it for the ExactFlat workflow.
Okay, thanks, Luke. I just want to say a couple of things just as we close with the ExactFlat portion. It's Eaton here again. So the real opportunity here is you're going to take your manual process, which historically has worked very well. That's because it just has worked very well. But it's a manual process, and it has to be repeated for every vehicle you do. If you undertake an opportunity like this, you're going to switch your process from manual to digital. You'll start with your data capture, and then you make your templates. Now, these templates could be, the advantage is that you can resell the templates. You could create a business around reselling the templates. You could also expand your business into higher value custom graphics and vehicle wraps. And in this regard, you can subscribe to very, very, very cheap libraries or even free libraries of seamless textures, whether it be camouflage wraps, animal prints, whatever it might be. You could put custom logos on there. Luke just gave the example of the ground effects text, but you could put anything on there. You could put vanity, vanity text on there for companies or for individuals or whatever it might be. And those can be resold as well. And you could have a combination of these things where they're semi-prepared and then customized at the last second so you could do your work very quickly. So the real opportunity that we want to share with you is this is a way to get your job done faster, and it's a way that you could look at expanding opportunities for creating additional revenue from your efforts. So if you're going to wrap somebody's car, the result could be a satisfied, happy customer as you have today, in addition to a resellable template and a graphic that could earn more revenue for your business. So I think that there may be some questions, Grant. I'm going to hand it back to you to just say a few words in conclusion. But I'll just say that this process, depending on the complexity and depending on how much surface area you have to do, it can take anywhere from sort of like 10 minutes per stage, 10 minutes for scanning, 10 minutes for processing, 10 minutes for ExactFlat, on up to more lengthy projects that are more complex. So Grant, let me stop there.
Well, thanks, guys. Thanks, Luke. Thank you, Eaton. Yeah, like we were saying earlier, a lot of the scanning process and the mesh editing is really up to the scope of work as well. So we're just kind of giving you the tools in order to create some of these high value assets, especially to meet customers' needs. We're going to kind of open it up to an FAQ, and please ask both the Shinning 3D team on the scanner side, and then also ask on the ExactFlat side. We're going to be reading the chat and to kind of answering your questions. So, for example, Luke and Eaton, part of the process of exporting a mesh. You know, often or not, I'm exporting as an OBJ file for you guys. And is there a reason why I should only export OBJs over STLs?
Sure. So OBJ and STL are two very different file formats. With STL, the only information you're exporting is the vertices and triangles. So an STL file really doesn't have any concept of grouping or joined meshes. With an OBJ file, you can specify triangle groups or mesh groups. And that's what really allows you to export your part as 6 different pattern pieces. So for that reason, if you need to export all of your split meshes as one single file, OBJ would be the better format, and that's simply because it's more of a rich file format. It supports more information, more metadata, and specifically texture coordinates. If you're trying to move files between Blender or 3D Studio Max or something for graphic work, OBJ will support that, whereas an STL won't. If you're trying to export different piece groupings, with this part, we had it split into 2 different pieces. Grant, you originally split it up into 6 different pieces. All of that can be captured in an OBJ file, whereas it can't be captured in an STL file. And that's just because of limitation of the file format.
That's very interesting. I think someone's about to type up a question, but
Sure, I do see a question earlier from Louis Silva. In Geomagic Essentials, how do you build a symmetrical plane for the Mustang scan?
I think Eric Lau, he kind of copied a video on this. I would recommend everyone to kind of go in there. But inside Geomagics, we can actually do a lot of like, planes, and then do kind of based off of symmetry. That could be a thing that if you guys are curious about, you guys can contact one of the partners or Shining 3D, and we can kind of go over more of that in Geomagic Essentials. I know I kind of sped through it a bit, kind of just go over as much tools as possible. Some of the tools I touched don't necessarily have to be touched. It's just kind of there. I think there's a question here. Does this process save you in wastage of PPF?
Yes, so with this process, you can preview in real time in 3D and in 2D what your pattern is going to look like. So if you notice any kind of obvious error with your pattern, you've spotted that error and you can fix it before you've even cut out any kind of material. Because we also show you where the strain is, ExactFlat can be used to highlight different areas on the mesh where you may have high strain. For instance, on this part here, in these corners here, you might have to add a dart or a slit. And if on your pattern after flattening, you notice you have an area that's red, that's an indication that you've got very high strain in that part. So that is ExactFlat's way of telling you you've got very high strain on your part, and that's an indication that you may have to add a dart or a slit. So it's very easy to see these types of scenarios in 3D before you've even cut out any kind of film. That said, our flattening process does produce very accurate patterns that do fit very, very well. So with this method, you can potentially nest your pattern pieces in a way you might not be able to do with a manual drape and tape type flattening. So you can further reduce your material costs that way as well. So if I were to rotate this piece around, I could probably tuck it up here and here even further, and I could nest my pieces a little bit more efficiently, which would also reduce the material usage.
That's cool. I think we got another question. When scanning with non-surface conforming triangles, I believe they're referring to the triangles that I made with the markers. Is there a trade-off of ease and speed of scanning against cleanup in the CAD comparison to the use of stick-on conforming target dots? So this is kind of like a little hack that I've kind of come up with. For some of the large surfaces, it works really nice because you put some fun tack on the other side and it just goes on really easy and so forth. The only difference is when you do it that way, you might want to be careful about features that you're hiding behind those triangles. So, for example, when I was showing off in Geomagic Essentials, doing some alignment or filling some holes, maybe you might miss some geometry that is very important for the flattening process. So you should maybe keep that in mind. In some cases, you can move around the triangles later. If a triangle covers up one spot, you can move them later and rearrange them in a different scan. It does help with the amount of setup time, because it takes me a minute to put those triangles on and a minute to tear down. Whereas maybe putting markers onto the body of the car, you're not really hiding any features, but you do have a longer time to put markers on and take markers off. So I think really these are just tools to help you guys in order to make your business successful. Try them both ways. Try them just putting on the markers onto the car, and try don't putting markers on the car and putting them on triangles like that. So I hope that kind of answers your question there. So another question for the scanner side. To avoid any scanning spray, white powder on a customer's car, which scanner is better between the Pro HD or the HX, or the free scan lineup is more appropriate for the application? Well, if you don't want to use powder, laser is the way to go. So HX and the free scan lineup are both laser-based scanners. So you're able to scan surfaces that might be very glossy or very dark, or even a lot of times very chrome-like. And it's also very easy to scan maybe outside, where as if there's like a lot of daylight or ambient light, often or not, structural light scanning might be not so great. You might have to put a tent or an awning over the car while scanning, whereas the laser mode can deal with more natural light out inside. There are some sprays, though, for the Pro HD that can disappear in 4 hours. So I've tried that on cars as well, and with great success, not damaging any of the paint job on the car. Again, these are just kind of tricks. That spray, though, is AE sub. They have one that disappears in 4 hours and one that disappears in 8 hours. So, but if definitely can't use spray, HX is really good for this process. And if you need a little bit more higher accuracy, under 30 microns, 25, take a look at the free scan lineup. It does have a really good fidelity for the between the scan and the object. So I hope that answers your question there, Jerry.
Yeah, I'll just add to that, Grant, that in terms of accuracy, the accuracy that you stated at the beginning of 0.4 millimeters or 0.04 millimeters and 0.05 millimeters, that is more than enough accuracy for this type of application. The scanner is easy to use, and the accuracy is more than what you need. So it's a great entry into the scanning workflow. Getting into microns, this type of application doesn't really need such a high level of accuracy. But if you're using it for multiple purposes, for example, paint protection films, say for example maybe interiors and so on, then you can consider the higher accuracy scanner. But I just want you to rest assured that the scanning process you do today will easily achieve the template making requirements from an accurate perspective.
Well, that's really good to hear from you guys. We also I kind of went over it very briefly. With the HX, we had multiple features besides just using the main feature, which is the laser mode. I did have the whole scan of the engine bay that was not based off of any markers. It was just based off of texture-based alignment system. In that case, it was able to pick up all the information really well. If I wanted to include that into the main ASC file, I could export that as an ASC. as a point cloud, and then also the body. But I would make sure that if you're just scanning panels, you just scan what you need and don't try to scan more than what you need, because you're trying to scan as fast as you can and turn around the data as in a prompt time as possible. So I believe for the flattening process videos, we will actually have this video available for you guys as well, what we did today. And I believe on ExactFlat's website, and you guys correct me if I'm wrong, you guys have some really excellent tutorials too on ExactFlat and the process.
Yeah, the process is very mature at this point. There are many companies in many different industries, and if anybody has an interest of learning more about ExactFlat, we do have some excellent tutorials. Even if you're in regions where English isn't your primary language, we have them subtitled in English and sometimes in other languages to make it easy. But I would say that, you know, this is a new technique for everyone, for most people out there, of using a 3D scanner and then digital methods. But this technique is here to stay. About 60% of the new passenger vehicles in the world use ExactFlat for their automotive dashboards and A pillars and molded plastic and so on. And that is a process that is using a technology similar to the graphics that Luke had showed you in this video. One of the advantages of what we're showing you here today is flow across pattern boundaries. Now, we only had 2 pattern pieces here, but had we had more, the reason why you want to use a technology from 3D to 2D for your graphics is that you get flow across the pattern boundary. So for example, if you have the front bumper, the quarter panels, and then the hood, you want those graphics to flow in continuity between those different sections of the vehicle. So vehicle wraps with graphics are something that you're considering. Then we have a lot of OEM, like for snow machines and other types of things that are traditionally very heavily graphic laden. They use ExactFlat for those type of applications. But to Grant's point and his question, if you're interested in learning more, there's a lot of great tutorials that kind of break the process down and show you how to do it.
That was great. I think pretty soon we're going to be wrapping things up. I see one more person typing out a question. We'll probably give another 2 minutes. Is that okay with you guys too? Another 2 minutes and we'll wrap.
Yeah, we're fine on this side, Grant. We're totally fine.
Oh, great. Yeah, a lot of great questions, guys. Here's a quick thing. I know we were talking mostly about paint covers, but kind of explain some other applications that might not be so obvious as paint covers. There's a lot of cool things using for flattening technology. Maybe can you cover top 5?
Yeah, so there's sort of 2 perspectives on this, Grant. There's an OEM market for original equipment manufacturers, and then there's an aftermarket. So if you take for example in seating, there's automotive manufacturers that use ExactFlat to create their seat designs, the OEM seat designs. And then there's aftermarket. If you wanted to do a retrofit of an interior, for example, with seating, then you could use ExactFlat and the Shinning 3D scanner, scan the seat in 3D, and then you make your your seat patterns that way. You can use it for almost all parts of the car that are covered in fabric or that are soft and fabricable. So the entire vehicle, the interior, the seating, you can use it for furniture, for example, upholstered furniture. If you have a furniture stump and you've been patterning manually by draping and taping your patterns, you can use the scanner to scan those, to capture the data and the geometry of the furniture, and then make the patterns digitally using ExactFlat. You go through the same process. So there's a generic process where you capture data that uses the scanner. You will process that data to clean it up, make the edge boundaries crisp, make the pattern relationships and the pattern shapes analogous to what you want to make, and then use ExactFlat to flatten it out. For marine, from all parts of the marine industry, the boat hulls, the boat canvas, and marine interiors. We have people using ExactFlat for super yachts, where they used to have to park the yacht in the in the marina for weeks at a time and to be out of service. And now they go in, they scan everything, and then they come back and process all those scans, make the patterns. A couple of weeks later, they bring the boat back and they install everything. The same process applies to aircraft. So if you look at aircraft interiors, I'll give you an example, say for private jets that do undergo a regular update and refresh of their interiors. Taking a private jet out of service for a number of weeks or a number of months while you're waiting for your draping and normal manual pattern making processes to unfold, that can be extremely expensive. So if you move to digital, where you scan the interiors, you scan the seating, you scan the other elements that you want to update, you can do that work in parallel while that jet is still in service and flying. And then when it comes time when the patterns are done, you just go and take it out of service for a short time and you install it. Anything that is soft and is flexible, that covers an object, you can use ExactFlat and is a candidate for 3D scanning, especially in the aftermarket, where a lot of these things are done by OEMs, but the aftermarket is growing pretty rapidly. And I think in this particular regard, just in regard to paint protection film, it does take a long time. This is a craft. This is an art, being a paint protection film specialist. But there's an opportunity to apply additional services for your customers. And when you do one project, you've got a asset that you can use, that you can sell and make the next project quicker. Or, whoops, my watch is listening to me. You can make your next projects quicker, or you can sell them to other paint protection, outlets. And there's there's opportunities outside of the normal automotive application of these things. You can, especially if you're talking graphics, you can get into snowmobiles, ATVs, side by sides. There's marine applications, signage displays. There's a wide field if you become an expert in scanning and then processing those scans to make patterns. Let me stop there, Grant.
Oh, good. Well, when I started learning ExactFlat, the first thing that came to mind was I love golf. I was thinking about scanning golf carts, and what would that be with graphics for golf tournaments and so forth for the golf carts, or that would be really interesting. To your point, is to put graphics onto things for like specialized events.
Well, if you look at, sorry to interrupt you, but if you look at applications like that, it doesn't even have to be a one-time wrap. You could scan the golf cart, apply graphics to it. Could be an advertising opportunity. The advertising alone would pay for the work done to make the templates and so on, and you could do that over and over and over again. So it's it really will come down to how creative you want to be, but the opportunities are there, and these are opportunities that are real, and you're gonna get them today.
That's amazing. I think we'll have time for one more question. The question has arrived. Can we use ExactFlat if we don't have Rhino or SolidWorks? I work with Siemens NX. So
the answer is no.
Yeah.
No, ExactFlat is only available in Rhino and only available in Rhino and SolidWorks right now. Rhino is very inexpensive, and we often, I don't know if we're doing it for this particular webinar, but we can bundle in Rhino. So you can output your files from Siemens, and then actually you don't even need, sorry, let me stop there. You will scan your product in using the EinsCAN, and then you'll import it directly into Rhino and ExactFlat. Siemens, we do not plug into Siemens. We don't have a 3D to 2D application in there. There's no graphic application there. So unfortunately, if you're a Siemens user, if you want to use the 3D scanning and do this kind of thing, you're going to have to move to get an additional applications with Rhino. And Rhino is our recommended application because it handles meshes very well.
That's great. Well, we're going to wrap things up. If you guys have any more questions, please don't be afraid to contact sales@shine3d.com. We will help find a local partner, one of our local partners around the globe, to help you guys incorporate the ExactFlat workflow with our iScan scanners, 3D scanners, and we can see how that fits into your business plan. But don't be afraid to reach out, and if you need any more explanations or a little bit more detail on workflow, again, we're really happy to help. Our partners are happy to help, and ExactFlat, you guys are amazing. And thank you again, Luke and Eaton, for joining us today, and for such a wonderful presentation as well.
Thanks, Grant. On behalf of ExactFlat, thanks for having us, and we look forward to working with you and your team. And I would just like to encourage people to reach out to Shinning 3D. And if this is something that is compelling to you, we will help you make it successful. So thanks again, Grant. And Luke, thank you very much.
Thank you.
Well, thank you everyone for joining today. Again, don't be afraid to reach out, and we will have this video available later. Until then, hope you guys have, for more Shining ideas, contact Shinning 3D. Take care, everyone. Bye-bye.
Bye-bye.